Okay, well, here we go. There, I did my last cinematic pan for this entire video. We're here to test this setup. How do I put this? I have made it publicly known for a long time that if I see something that I like or I think that's going to work that somebody else has come up with, I have no problem with going, oh, let's go try that. So what we've done here is build just a classic 4-transistor HG amplifier with all my components, my input transformers, my output transformers, my power wire, my setup, the way I like to do things. What we stacked on top of that is a little bit of Dave made / BM technology. Chris and Dave and those guys back there, they came up with this flyback idea. And their design is just a piece of wire that goes in the input transfer or the output transformer, loops around and comes back out. Another piece of wire that goes in the input transformer, loops around and ties back into a 100 ohm resistor that they leave just floating out here in the middle of the circuit. And it works with inductive coupling, okay, for the flyback circuit, versus this setup, which we've all come to love, know, and use, which harks back from the messenger, well, basically the pre-dynastic period of amplifier building. There's a physical connection, and we're using this disc capacitor as a blocker to block the DC voltage, but it's giving it a physical pathway for the overflow RF that's not able to go into the transistor on this transformer. It gives it a dissipation route. Okay. So, I wanted to create a circuit that I know that I'm very intimate with, okay? Something that I'm in complete control of all the materials, and I know what the tune is going to be. Specifically, these set of capacitors, and then this set of capacitors over here on the output tune. So I already know what this thing should do here in this environment, here on the healing bench, okay? I know what this will do. If I put X amount of watts in it, what's it going to do? If I put this kind of power into it, what's it going to look like on the spectrum analyzer over here? What am I going to have for input reflect? What am I going to have for output reflect? What are we going to have for side harmonics? I know all of that. So this weekend, I don't know why, I started building this Saturday night, and for some reason I woke up Sunday morning and this is the direction I went. I don't know. I just wanted to try it. It's just an experiment. And I'm not here to put down negative, positive, nothing. I'm just saying I wanted to try this. So how do we try it? We put it in a controlled environment, and we give credit to the people that came up with the idea. It was not my idea. I give credit to the people that did it first, which was Dave and them boys in the Dave Made camp. Which the more that you study that legacy, everybody's got a different story. Everybody. It always blows me away with so many people that jump up and go, oh, I take credit for that. Oh, no, I did this first. I'm not that guy. I'm just a humble little servant to the amplifier community, I guess would be the best way to put it. And I just sit here and I like to play. I'm a tinkerer. So we're going to start moving the camera around an awful lot. And if you're prone to motion sickness, well, cover up one eye, because here we go. First, we're going to zip over here. We're going to take a look at our spectrum analyzer. We're going to bypass our amplifier. Amplifier's off. Hello, 1 2. Audio 1 2 1 2 1 2. Now we're going to look at this with eyes wide open. I'm going to try and do this test without cutting away. We might take one little break, as I got to flip the amplifier around a bunch to remove some parts. So that might be our only break. But that is our principal test. This is what we're putting into it for input power. We're at a negative 50-ish, 45, what is that? Negative 50, starting at 0. We are from 0 megahertz all the way through 264 megahertz. Wide, really wide. Hello. And we can see that we have pretty much no real side-to-side noise coming out of this thing. Well, we shouldn't. It's a Derail Striker 955. And that's another thing I wanted to get up on my little high horse, my little hobby horse about. Just because you've got the radio built by, you know, so-and-so, doesn't mean you're going to sound just like so-and-so. There's this knob that's right here. Okay? In my radio, I got a whole bunch of other knobs down the side. But this knob right here, most of the time, should be run like that on a lot of radios. We're in a sealed environment over here. I'm not using this to talk to the outside world. And I can run that all the way open if I want, because nobody's listening to it. But you'd be amazed how many people I hear are bagging on this or bagging on that, and they're like, it sounds horrible. That guy sounds horrible, and he's got one of his radios. Yeah, well, unless you've got self-control or you understand to set your radio up properly, you're going to sound like ass. You could have the best radio in the world, but if you got your mic gain too high or dead key too high or a whole lot of variables, you got the wrong kind of mic, or you got too much audio going into your mic jack, it doesn't matter if you're the best radio technician on the face of the earth. Sometimes the end user doesn't really quite understand what they're doing. So I really want to encourage everybody, take a minute, step back, take a little bit of a deep breath, and go, maybe because so-and-so sounds horrible on the radio, it's not the radio technician's fault. It might be the end user's got his mic gain too high, or he's got like a power mic going into an EQ plus, going into another EQ plus, going into another EQ plus, and the radio's just dealing with what's getting jammed into it. You don't know. We're going to be dealing with the Striker today, the Derail Striker 955. Then we're going to come over here and we're going to eventually end up over here on the SR490. So the 955's got its own watt meter. That's a 5-watt slug and reverse. It sits directly with a 1-foot coax jumper off the back of the radio, going to a 12.5-foot long piece of coax coming down here to the input. So I have all my radios color coded. I don't know if you guys have ever picked up on this before, but see how it says black coax, and over here it says red coax, and you can't really quite see it, but on top of the Striker I can see it because I'm like 7 foot tall. But right up here on top, there's a little label that says blue coax. And so when I'm down here on a workbench, I can very quickly just pick up my column of coaxes, and I've got them all color-coded heat shrinked. That's the 490. I know that without even having to look it up. Okay. This is a 2950, just by their color code. So the black coax here, black heat shrink, is the Striker 490, or 955. So let's go over here and let's do a unit of measure. Let's go take a lap around the band real quick as we take a moment to look at this. That's a 1,000-watt slug in peak, 1,000 in average, and a 5-watt back in reverse from the 10,000-watt dummy load. Nothing outside of the normal here. So we're trying to establish a flat baseline response. Now, I have built this differently than the way the Dave May guys do. Okay, so this is not an indicative test, or is not an actual representation of the way their flyback circuit works. But it might become that. But I'm just saying that there's a whole lot more inductor because of the solder tabs that I wanted to add. Me, wanted to add. And there's also a disc capacitor, a 103 disc capacitor that's going from here down to the transistor pad. Let's get what I would consider to be a background radiation exposure here, heat radiation. So we've taken our picture. We'll make sure to insert this somewhere in this video, someplace. So let's establish our drive levels. Hello, audio. We're going to run at a nice solid 15 volts on the button. So 14.8 on the inside of the amplifier. Radio is seeing hello 14.1. That's another thing, is these voltmeters on the front of these radios are crap. Absolute crap. Hello 1.2. So I'm putting 15.0 according to the Fluke. This meter's telling me 15.2, and when I key it's dropping, but you got freaking 8-gauge wire going up from the amplifier all the way to the, or not from the amplifier, from the distribution block all the way up to the radio. Come on. It's not dropping. It's just the meter's crap. Okay, 100 watts in gets us, hello, 1.2, 1.2. Gets us 800 out. Hello, audio. About 200 bird. I want to slide the camera over just a little bit. Change our angle of attack on the front end of the striker. There we go. So let's go up here. We're going to take a quick look at the front end of the striker. Hello. Now that should read 1.0 on the input. Let's go see how that same unit of measure is expressed on the bird meter. Hello, 1.5 watts of input reflect. A little high, not something that I'd consider to be up to snuff. But with this particular capacitor set up on the input and the particular capacitor set up on the output, it should be flat. So then we got to go look at what we've done differently in the circuit and see how it affects it. That's what we're doing. Hello, audio. Now this is what's really interesting to me. Hello, audio 1.2. Now, in theory, I should be using like 1,000 hertz tone generator boop, going into this thing. Growing up working in a CB shop as a young man, I swear to God I was never going to have one of them stupid beat boxes in here. Just wasn't going to do it. I've got a signal generator up here. I never use it. Never. Never, ever, never. And the way it's hooked up is up here. Where this goes is up here. And if I do go to ever use this thing, it's like impossible to hide. Because the way I've got it set up is a direct inject off the 4-pin microphone. And this literally hangs out the front end of whatever radio I want to plug it into. There's like 3 inches of dust on that for a reason, and it sits up there all the time. I'd have to completely reteach myself how to use that signal generator because I don't use it for nothing. I have my phone. I just spin up 1,000 hertz tone if I need it, which I never do in what I work with out here. So, okay. What we have seen is general broad spectrum noise at a very, very, very precise interval and in a decaying signal pattern. So it doesn't matter if I take my pickup coupler and I point it in reverse. It decreases the sensitivity. Or here, we'll make it so it's now metering forward. the harmonics are still present. That is not a phenomenon that I normally see. Now, like I said, once again, this is not the way Dave and them guys design it. Okay? I have modified this design. So this isn't a true representation of their circuit. That thing is working. These resistors are doing their job. They're taking the overwhelmingly more input power. We're putting technically more into this circuit than these transistors are able to fully absorb. And they're actually doing their job. So what I want to test now is, this is my idea of how this circuit should be built. My idea, not their way of doing it. This is my idea. Is I want to remove these disc capacitors out of the circuit and make it so that these just float freely electrically, and it's just working with pure couplants. Okay? The field flux inside the transformer is going to allow it to couple to the wire instead of having a physical pathway through the disc capacitor. I want to remove the disc capacitor from the circuit, and just for my own curiosity's sake, I want to see how this works. When I first started doing this stuff, you guys, I had no one out here to teach me anything. I didn't have fancy tools like this. I mean, like, I can remember sitting down and dreaming the day that I'd be able to afford something nice like this. Okay? I didn't have the fancy spectrum analyzer. I didn't have all the fancy watt meters. I simply took every penny I made for like almost a decade and put it back into the business out here, into the workbench, so I could have these nice measuring tools so I could learn, teach myself more efficiently. So, experimentation, changing this, changing that, only changing one thing at a time, and seeing how it changes the entire circuit. It's all a game of just, well, passive observation out here. So, now, soldering iron should be heated up at this point. We've got our baseline measurements. Let's go ahead and let's pull these little disc capacitors out of here. We'll set them aside probably over there someplace, and then we'll redo this test. And I want to see what it does power output wise, input reflect, and also what it does on the spectrum analyzer. Okay. So, put the fan on it to cool everything down. Got our picture. Now, let's go ahead and let's run this. So, put this in standby. And we're getting roughly 800 watts out before. Hello. Same 100 watts drive going in. Hello. Same output power. Hello. Audio. Ooh. Okay, and then back up here. Hello. Slightly less by half a watt, and all we did was take these capacitors out. They're no longer present. Focus, focus, focus. There we go. So, let's go back up here and let's look at the face of the striker again. Hello, 1, 2. Still seeing that 1.5 input SWR. But the harmonics, that's the sticking point. So now, let's go ahead and let's test something else. Let's grab our frequency selector. Hello, okay. Hello, audio. You guys see what I saw? Let me show it to you again. So now we're going to look at both meters. We're going to look at the striker, and we're going to look at the reflect meter. Tap this up just a hair. Lock this down. So, hello, audio. Hello, audio. Let's change our frequency. Hello, audio. That tells me everything. Okay, so let's say that I've spent a little bit of time looking at this stuff, right? Just a little bit of time looking at this circuit. That simple little test of changing the frequency gives me a window behind the curtain, okay? Lets me look behind the curtain and see what's going on. That simple little test tells me that we don't have enough capacitance on our output circuit. It's just something you pick up. You spend a lot of time looking at the same set of meters and you play with stuff a lot. Everybody automatically assumes that this is the total end-all bee's knees end of conversation when it comes adjusting your input. No. Remember, these, the front and the input and the output are tied together. Let's take a quick measurement here real quick. This is where we need to make our adjustment, not here. And it's just experience that's telling me that. And I bet you I'm about 10 or 15 puff off of being flat resonance here. If I had about 10 or 15 puff worth of capacitance here, I bet you the input will drop down flat. Now what will that do with the harmonics? I don't know. What this is telling me is that there's more inductor inside the cores than what I'm used to playing with. And it's representing itself by changing its overall reactance to the outside world. Okay? Well, there's more inductor here, okay, and there's more inductor here, okay. That means we're going to have to make a small adjustment here and maybe a small adjustment here, but I just want to add about 20 puff over here in a corner and let's see what happens to our input reflect. Okay, so I changed perspective so you guys can see what we did. I added a capacitor right here, total of 35 puffs worth of capacitance. Input circuit stayed exactly the same. Let's go up here and take a look. Let's see how this changed the universe as we know it today. And there we are. Okay. So we were seeing about 1 watt worth of input reflect. Hello, 1 2 1 2 1 2 1 2. Audio 1 2. See how that works? So let's go ahead and redo our measurement again. Hello, 1 2 1 2. That was just a hair over 1 watt. So we took a half a watt of input reflect out of it. Hello, 1 2 1 2 1 2 1 2. Interesting, yeah? Okay. Now I don't ever sit here and talk tune. I don't. That opens a can of worms. Okay, everybody's got their opinion on how this needs to be done. All right. So let's just say I've spent a lot of time looking at these meters, and you figure out what works really good on a real 50 ohm antenna, and then you bring that back over and you drop it on this bench, and then you look at it into a dummy load. There's a huge electrical difference between a dummy load and the real world antenna. Huge. Huge, I'm here to tell you. So you gotta catalog all that information in your brain and understand what you're looking for here to know what's going to work well on the outside world. Here that are always tuned on an antenna, which I don't ever suggest doing, ever. Ever. Hello. So we picked up a little bit of bird, but no more peak. Hello. But the $64 million question is, what do we look like over here? Hello, audio 1 2 1 2. Yeah. Ick. Okay. Now, let's change our input capacitance just a hair. Just a smidge. Just a smidge. Okay. So we added 30 here. We took 30 out over here, is what it wants. And the end result is this. Hello. Same amount of power, but now all the meters are happy at least. Now, once we get this little baseline tackled, now we've got to go and figure out what our harmonic issue is. Hello, 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2. Bump this up. Hello, 1 2 1 2 1 2 1 2. Hello. Okay. Hello, 1 2. And what we're looking for is the flattest overall response from channel 1 to channel 40 or whatever in your frequency width that you want to play with. You're looking for the flattest, lowest input SWR. Not just on one frequency, but across the whole band. And that usually is a pretty good indicator that you've got what they call the Q, or the reactive response of the circuit, the Q, pretty well laid out. So this is a little deceiving. There isn't just 1,000 puff here. There's also extra 220 puffs worth of capacitance down below. You might have caught that earlier when I had the amp flipped around. Maybe you didn't, maybe you did. So now we're going to play around with these capacitors because we know we've got the input and the output tune in balance, okay? And I'm trying to understand now where all this spurious noise is coming from, which is something very uncharacteristic for me to deal with. Hello, 1 2 1 2, which really isn't all that bad. That's bad. I bring that carrier up. Now we're putting out a 200 watt carrier at the moment. 200 watts. That second harmonic, which is about 35, 38 dBm down, that's no good. That's going to be way out of frequency resonance for any 11 meter antenna or 10 meter antenna, which is going to cause false reflect. So let's go play. Well, this is an interesting result. So what I did is I got rid of the single pass through here and I put two passes. So it goes in, makes a turn, comes back and goes back through again. Same thing on this side. I just changed the output side. Let's see what we got as a result. Hello. Picked up about 50-60 bird, but lost 50-60 in peak power. Let's go look at our input tune here. Sorry guys, shooting this live on the fly is not always as smooth as you'd think. Hello, 1 2 1 2 1 2. I think we can all see hello how that changed that. Let's go ahead and we'll do our ping pong test, is like what I like to call it. We'll go low and then we'll go high. Hello, 1 2 1 2 1 2 1 2 audio. Now we'll go high. Hello, 1 2 1 2 1 2 1 2. Okay. So that tells me that the circuit's still perfectly where we need it to be. But this over here, there we go, has come down quite a bit. So now we're down to something that would be kind of acceptable. We're at negative 35, maybe 36 on that second hump. It was just interesting. This is an interesting little test. I mean, we haven't built anything here that can't be undone very quickly and change back to something that'd be more of a modern, not modern, but more of a something that we're tried, true, and tested. I could probably change the input widening as well. This is making the circuit run really hot. That's the other thing. I mean, we're at 184 degrees, 195 degrees. On these flybacks. And we haven't even fully saturated the circuit yet. I don't know. This is interesting. It's something I wanted to try. I'm not saying that this is bad. Maybe I don't understand how to set it up. I'm not saying anything ill of it. I'm just looking at what I'm getting for actual observational results. So now we know where this stands. Let's go ahead and I'm going to pop all this out of here. I'm going to take all this out, and we're going to go back to something a little bit more traditional with the standard flybacks. And we're going to see how that changes the circuit overall. So here we are with our more traditional flyback circuit in here. Let's go look at our watt meter. Same amount of drive as before. Hello, audio, 1, 2. Hello. So gave up a little bit of peak power, about 50 watts. Got the same amount of bird. Spectrum. We're way down there. Now let's look at our input reflect. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Hello. Interesting result, yeah? You see what I'm seeing? Here and here. Let's go do our high-low test. Let's see how wide our Q is on the box. Hello, 1, 2, 1, 2. And let's go low. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Much. Hello, audio. Much wider. Lot smoother, flat response. Little bit less harmonics. Now, this isn't the end of the conversation. We're still low on power output. It's got something to do with this setup here. So we're going to drive this a little harder here in just a minute. We'll see if we can get the rest of the power out of this thing. But this isn't the end of the conversation on the flybacks. I'm going to try this in a different circuit, a little bit more traditional setup here in the future. So I'm not saying that this circuit doesn't work. It works great. Does it work well with my transformers and the way I like to build? I'm sure I could modify it if I want to spend more time messing with it. Make it work just more than adequate. Is what it is. But this is an interesting test. I learned a lot. And, well, I need to finish this little project up because I've got to spend the next 3 days, 4 days working on an SB220 for a customer that I'm really looking forward to working on something for. She has been totally kick-ass, so I can't wait to see what the end result is going to be with this box that I'm working on now. But let's go ahead and let's step the drive up and let's see what we end up getting out of it for max saturated power. Well, let's do a quick study on maximum power. So we're still on the 1x scale. So just going to show you drive. This is a 2950 going into the 2-pill. I got the mic gain turned way down on the radio, by the way. Hello. About 250 watts going in. Hello. Off to scale. I turn the mic gain up a little bit. Hello. Make it really disappear. Hello. On the stop peg. So let's jump this up again. So now we're in 2x, so full deflection over to the right is 2,000 watts. It's like I've said in about 1 million videos. That mark right there, between the 40 and the 60, or the 20 and the 30, or the 10 and the 15, that big hash mark's 1,000. Every major graduated hash mark after that represents in 200 more watts. Hello. Audio. About 12 and some change out of it. That's what we should get. But the box won't live very long there. Hello. It'll live forever. doing roughly about 1100 to 1000. Hello, 1 2 1 2. But with more drive, it does pick up. Here's an interesting characteristic we've just observed. Now we got our side harmonics, our side bands. I call this a win. Not the squeakiest, cleanest thing I've ever made in my life. Man, it sure puts out the power. Well, I'm going to take some notes on this before I forget them. Because as soon as I go to sleep, some of this knowledge will leave my mind, just like it does everybody else's. Sit down, draw this all out, make capacitor notes. For some reason, it didn't like having the extra 250 puff down below. It wants to have it up top. What I mean down low is farther down the face of the transformer. The placement of capacitance is a really big deal, and also the legs, the lead length off the capacitors, makes a huge difference in how the circuit works also. Well guys, I'm going to run. I'm going to go do other stuff. I appreciate you all tuning in here this afternoon to follow along and check this out. Remember, first time watching and you're not subscribed, take a minute. Click the subscription button, smash the bell, that way you can get notified when I'm out here doing crazy stuff, which is basically every day. So, learning, and teaching all in the same breath. Well, gentlemen, I've got to go. I got an SB220 restoration that I'm going to do this week, and then I'm going to start on the 4-tube 3500Z box that has been waiting for my attention. So, yeah, I appreciate every single one of you guys. I really honestly do. Big shout out to Siglent, big shout out to Excess Power. A little bit of a nod and a thanks to Bird and Coaxial Dynamics for keeping me up to date and keeping my equipment certified. And on that note, I appreciate you. We'll see ya. Bye. I totally forgot. Hey, this is a masterclass build, and this is for sale. I'd probably like $850 for it, somewhere in there. It is Class C. I guess I could add sideband to it, but I really don't want to. It's all murdered out on the inside. Everything in there is black. Black wire, black, and black. So, just real quick, I want to show this to you. So we're on the 955 Striker. Hello, 1 2. Hello, 1 2 1 2. Picked up a little bit of bird by moving those caps around. Got our same good peak numbers, about 800 watts, which is about what we want. 8 to 900. HGs will live forever. So, no, this thing's for sale, and for all of you that, well, didn't tune into the end of the video, you're not actually getting to see the whole end of the story, but those of you that watched here to the very end, win for you guys. Gentlemen, I gotta run. I appreciate every single one of you. Click, click, click.